Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing, it's timesing the x by minus 6. So I'm going to divide both sides by minus 6. So that gets rid of the minus 6 on the left hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down. But here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts, so plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets, so 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the the coordinate is this one here, and so that would be -4, 1. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table, and we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40, and we can see here that that was, just get rid of that, that was between, like that was in this group here. So that is 0, and I'm just going to use M for money, 0 to 80, and the frequency is how high it is, which is 10. The next midpoint is here, so that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally the last midpoint is here, which is obviously 200, and that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability customer spent less than 160, so that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. Integer just means whole number. So we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going till I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7, and 8. So I'm going to start just by writing out the equation. And I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully. So we're just going to expand the brackets, 7m plus 70. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angled triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle. So it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it'd be a squared plus b squared equals c squared, but this time a is 39 B we are given as 47.148. We've just worked that out. And we're looking for C. In fact, we can call it X now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to X squared. And we just get our lines in because we need to square root both sides. And we get 61.188 blah 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 is equal to X. It says it wants its two decimal places, so that will be 61.19. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25, should be here, and then across, and that's how we would make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated. And what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising, because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u, and there's just a u on both of them. I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got well, we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So we're going to first of all work out the curved surface area, which is just this bit here, not including the top and bottom. And the formula for that is 2 pi r h. And the h is this bit here, so it's 2 times pi times the radius at the top, which is 12, times the height, which is 19. And that gives us 1432.566, blah, blah, blah. Next, we're going to work out the area of the circle at the top. So circle area. And the formula for that is just pi r squared. So pi times 12 squared, which will give us 452.389, blah, blah, blah. Now there are actually two circles, so when we work out the total surface area, so total surface area, we add the curved surface area to two lots of the circle surface area, or areas of the circle, because there's one circle at the top and one at the bottom, and that gives us 2337.344 blah blah blah, and two decimal places, that is 2337.34. To find the gradient, we need to first of all find two coordinates we know. So I'm going to pick this one and this one. And to find the gradient, we're just going to draw a right angled triangle between them. And the gradient is the change in y over the change in x. But here you can see that we've gone down 3, so it's a negative 3, it's gone down 3, and we've gone 1 to the right. So that's going to be minus 3 over 1, or just minus 3. So the gradient, a different definition of it, is how far up we go when we go 1 to the right. So here we've gone 3 down, so it's going to be minus 3. So to find the gradient, we need the formula, or the equation, in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6 because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. To rearrange this, I'm just going to write out the equation again. And I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism. So the volume will be the area of the cross section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now a and b are the two parallel sides, which will be this one and this one. And then the h is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything for this will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do. But I think this is a really tricky question to do without a Venn diagram. So it says that they picked two activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in let's just show it. The total number in the sports circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X, take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got x plus 2x, which is 3x. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3 over 5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3 over 5 times 2 over 4. And I realise I could cancel 2 over 4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4, 3/4. That would be 6 over 20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6 over 20 plus 6 over 20. And this is the probability of different. Which will be 12 over 20. Now 12 over 20 will cancel to 3 over 5, or 3/5. The way you do this question is very, very similar to if it was 1/5 minus 1/6. You need to get the denominators to be the same, and then you add or subtract the tops. Well, be subtract in this instance. So 5 and 6, the lowest common multiple of 5 and 6 is 30. So I'm going to times the left-hand side, top and bottom, by 6, and the right-hand side, top and bottom, by 5. So times the top and bottom of the first one by 6, you get 6x over 30. Times the top and bottom of the second one by 5, you get 5x also over 30. And when you've got a common denominator, you just subtract the tops. So it will be x over 30. This question relies on the fact that you know what the equation of a circle is. And the equation of a circle is x squared plus y squared equals r squared. Now r is the radius of the circle. So when I rewrite this, and I write it with our 16 there, we can actually rewrite 16 as 4 squared. Okay, comparing this equation to this equation, we can see that r is 4. Now, this equation, the x squared plus y squared equals r squared, gives a circle with the centre at 0, 0, at the origin. So, it means that the radius will be 4, so the circle will go all the way up here, all the way across here, all the way down here, and all the way across here. Now, I am really, really bad at drawing circles, and so what I would recommend you do is use a compass and measure out 4 and join these up. I'm going to try my best. I don't have a compass that works with this graphics tablet, but I'm going to try and draw somewhat of a circle. There we are. That's probably the best circle I'm going to draw. So what you do is you just get a compass and put the point at 0, and then you would measure out 4 units. So measure it between the 0 and the 4, and then just draw a perfect circle round. So we're going to start off with the middle here, and then we're going to make our way to the right, and then we'll make our way to the left. So we're going to start off with 11 to the power of 0, and that's going to just be 1. Anything to the power of 0 is 1. Then we're going to do 11 to the power of 1, which is just 11. Anything to the power of 1 is itself, and then 11 squared is 121. Now this next one here, 11 to the power of minus 1, whenever you have a negative power, you just put 1 over 11 to the power of 1, or 11. Same with 11 to the power of minus 2, 1 over 11 to the power of 2. 11 squared is 121. So that would be 1 over 11 and 1 over 121. Okay, so this is not going to be too easy to plot because it's so difficult to get them low down, and we'll change the colour just to make it a bit easier to see. These are essentially going to be at the bottom. This goes up to 11, so that you can see that a little bit more, and then we've got 121, which will be there. Okay, so whenever you draw the curve, it does help you sometimes to turn your page sideways. I can't do that, unfortunately, but I will try my best. And you want just one smooth, continuous line. And I've kind of dipped a little bit at the end there, which I didn't mean to do, but any of these graphs will give you full marks. You need to make sure that it's one continuous line, that it goes through all of the points, and that you don't do any feathering like that. It's just one smooth line joining them up. First thing to notice is we actually have 2 radii here. So we've got this radius here and this radius here, and all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well, and we've got to write that down. So we're going to say angle OBA is equal to 19x, and the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here, and all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees, and this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180, and let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees, because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, it's just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. Now this question is on the calculator paper, so we know we're going to be using the quadratic formula because it asks us to leave our answers to 2 decimal places. So for the quadratic formula, we need to work out what a equals, what b equals, and what c equals. Now a is the number before the x squared, which would be minus 2. B is the number on before the x, which would be 13. And c is the number on its own, which would be minus 17. We're going to write out the quadratic formula, so it's x equals minus b. Now I always put these into brackets, so I'm going to first of all just do the fraction first, just so we've got nice formatting on it. So we're going to have minus brackets b plus minus the square root of brackets b squared minus 4 times a in brackets times c in brackets. Okay, and the reason we put the brackets is that it's very, very easy to make mistakes with the negatives, and so if you put all the numbers in brackets, you'll never make that mistake, and it's going to be over 2a, so that's 2 times minus 2. We're going to first of all put that into our calculators with a plus there, and when you do it with a plus there, you get 1.813 blah blah blah. And then what you're going to do is use your calculator to go back to this and change it for a minus. And when we do that, we get 4.686 blah blah blah. And so to 2 decimal places, we've got 1.81 and 4.69. If we start by labelling the sides and angles on this triangle, so we can have capital A there, little a, capital B up here, little b, then capital C here and little c. So we don't have the angles A and B, and we don't have length C, but we do have little a, little b, and the angle C. And there's a nice little formula to work out the area of this triangle. And that formula is half a b sine c. It's a nice little formula. And so we're going to do half times a, which I've said is 5, times b, which I've said is 4, times sine the angle, which is 24. And when you work that out, you get 4.067 blah blah blah. And when we round that, we get 4.07. Going to start off by labelling the triangle, and so we've got capital A here, capital B, capital C, and lowercase a, lowercase b, and lowercase c. It doesn't actually matter which way around B and C are, but capital A is always the angle that we're given. So we've got to work out whether we're using cosine rule, sine rule, or something else. Well, here we're given 3 lengths. Well, actually one of them is unknown, but there's 3 lengths involved and an angle, so that's definitely going to be cosine rule. So we're going to write out the cosine rule for when we've got a length, which is the one that starts with a squared. So it's a squared equals b squared plus c squared minus 2bc cos a. And let's fill in the numbers we've got. So that's going to be 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 22. And when you type that into the calculator, you get 6.184 blah blah blah. But that's what a squared is, so what we need to do now is just quickly solve that by square rooting both sides. And so we get a equals 2.486 blah blah blah. It says it wants its 2 decimal places, so that's going to be 2.49. I'm going to start by labelling this triangle, and so I'm going to pick a lowercase a here, uppercase a I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the C's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345, blah blah blah. So we're going to solve this. It's going to be a nice and easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah blah blah. And when we round that, we get 2.68. If we know that the roots are minus 13 and 3, and we know that the quadratic can be written out like this, then that minus 13 shows us that the first part here, first bracket, is going to be the opposite sign to that. So if it's a minus 13, that's going to be a plus 13. And same with the second one. If that's a positive 3 as the root, then the bit inside the bracket will be a minus 3. So A is 13 and B is minus 3. So we're told that y is inversely proportional to the cube root of x. And to get rid of this proportionality sign here, we just convert it to an equals and times the right hand side by k, which represents a constant. And we now need to figure out what that constant is. So we're going to feed in the value of y and x that's given to us in the question. So we've got 10 equals k over the cube root of 343. Okay, next thing we're going to do is we're going to solve that. So put our lines in. Now the cube root of 343 is 7, so we can actually just, it's a lot easier, and we're just going to times both sides by 7. So k equals 70, and we're just going to rewrite this, but instead of k, we're just going to write 70. So y equals 70 over the cube root of x. Whenever you're asked to work out a proportion of items in a histogram, you can actually do it by just counting the squares. So in the first bar, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 squares here. The next one, you've got kind of 4 half squares, so that will be 2 squares in total. And then we've got 4 squares in the last one. So altogether we have, for the amount of squares, we have 12 plus 2 plus 4, which will be 18. So it's 18 squares in total. Now it says that we're looking for between 25, which will be here, and 45, which will be here. So we count the squares in this little interval. So there are 3 here, and there's half a 1 here. So the squares between 25 and 45, I should say dash 45, 25 to 45 is 3.5. Okay, so we've got 3.5 in total, or 3.5. Out of a possible 18. So we just need to do 3.5 divided by 18 to work out the proportion, and that gives us 0.194 blah blah blah. It says it wants its 2 decimal places, that would be 0.19. We're going to start by creating a table of frequencies from this histogram. And so we are going to need our times, first of all, then our frequencies, and then we can add a midpoint and an fx column as well, which we'll need for later. So our times, then our frequencies, then our midpoints, then we'll do the fx later on. Right, so the first group is 0 to 10. And to find the frequency, I might as well just show this. So the frequency density is proportional to the frequency over class width. The class width here is 10, and the frequency density is 1.2. So 10 times 1.2 will be 12. And then the next group is up to 30. So we're doing 20 times 3.2. which will be 64, and then the final one will be 30 to 50. So again, we're doing 20 times 0.8, which will be 16. Okay, so we've got our table from the histogram, and we're asked to find the mean, so hence us doing the midpoint, etc. So the midpoint is 5, 20, and 40, and then the fx, we just times these together, and that would be 60, 1280, and 640. Now, something I said earlier is that the frequency density is proportional to the frequency divided by class width. It does tell us there are 92 people, and if you do the sum of the frequencies, you do get 92. So we know that it's a one-to-one relationship. Okay, so let's do the sum of the fx by adding up these numbers here, and you get 1980. So to find the mean, we do the sum of fx over the frequency, sum of the frequencies, and that will give us 21.521 blah blah blah, and 2 decimal places, which is what the question asks for. It's 21.52. So simultaneous equations we normally solve by working downwards and doing the circles and using the normal method on them, which is solving simultaneous equations by elimination. Sometimes though, when we've got a linear and a quadratic, which we have here, it's not possible to do that method. So what we've got to do is substitute one equation into the other. Now here, it's actually been nice to us in this question because they're both equal to y. So I can replace that second y with the 2x plus 11. I can just put that into that equation there, which is what we're going to do. So we've got 2x plus 11 equals x squared minus 5x plus 4. And we're just going to get everything equal to 0 so that we can solve it as a quadratic. So I'm just going to start by subtracting 11 both sides. So we've got 2x equals x squared minus 5x, what's that going to be? That's going to be minus 7. And then take away the 2x both sides. So we're going to have 0 equals x squared minus 7x minus 7. Now, we know this is not going to factorise nicely because it asks it for 2 decimal places. It's on the calculator paper. Chances are it's going to be quadratic formula we'll need, which we do. So we've got a equal to the coefficient of the x squared, which is just 1. B equal to the coefficient of the x, which is just minus 7. And then c equal to the number unknown at the end, which is minus 7 also. So we write out the quadratic formula. So x equals minus b, and always put them into brackets. So minus 7 plus minus the square root of b squared. So in brackets minus 7 squared minus 4 times a, which is 1, times c, which is minus 7. Oh, and all of that over 2a, so 2 times 1. And when you do that with a plus in that bit there on the calculator, we get the answer of 7.887 blah blah blah. When you do it with a minus, you get the answer of minus 0.887. And don't rewrite the whole formula when you change from plus to minus. Just use the calculator function to go back to this sign and just delete it and change it to a minus. But when we solve, we've got to find out the x and the y values. So we look at this first equation here, which says y equals 2x plus 11. It means to find out what y is, all we need to do is times it by 2 and then add 11. So I'm just going to do that with the first solution we have, so 7.887, blah, blah, blah. I'm going to times it by 2 on my calculator, and then plus 11. And that gives me the answer of 26.774, blah, blah, blah. Then I'm going to do that with the second solution we found, so the minus 0.887, blah, blah, blah. Go times it by 2, then add 11. And that gives me 9.225, blah, blah, blah. So to 2 decimal places, our answers are going to be 7.89 and 26.77, or minus 0.89 and 7.23. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. And let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now, if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. So we're finding the area underneath this graph, and that's how we're going to estimate the distance, because the distance is the velocity times the time. And so if we work out the area under the graph, then we've got the distance. But the issue is that we don't understand things like calculus yet, and we've got to use this thing called the trapezium rule. Now for the trapezium rule, what we do is we draw these lines up and we draw little trapeziums, like so, all the way up it, and in regular intervals. So here you can see the interval is every 2 seconds, and we draw these little trapeziums. Now it's often helpful to actually label them, so I'm going to label them A, B, C and D. And the formula for a trapezium, or for the area of a trapezium, is half brackets A plus B, close brackets, times H. Now A and B are the parallel sides, and H is the perpendicular distance between them. So let's do this for the area of A. So it's going to be half brackets. Now A and B are the parallel sides, so it's going to be this side here and this side here. So that would be 2 plus 1. H is the perpendicular distance between them, so this bit here. So it's on its side, so the height is actually the width, isn't it? So we're going to times that by 2, and that gives us 3. Okay, and you notice here that the half and the times 2 actually cancel each other out, so all we need to do is just add the A and B's together. So to find out what B is, we're just going to add the 1 and the 2, and B will equal 3. To find out what C is, it's 2 plus 5, which is 7, and to find out the area of D, it's going to be 5 plus 10, which is 15. So that's a bit of a quicker way of doing it than having to type it into the calculator each time. Then to find the total area, it's just going to be all of those added together, which will be 28. Now notice, this is useful for some questions, notice that actually there's a bit of a gap here, and I'm just going to shade it in green. It's a bit of a gap between our trapezium and the actual distance under the curve. So here the trapezium is actually adding on a little bit more area than we want it to. And what you'll find is a curve that looks like this, the trapeziums will actually add too much, so the area will be too big. And for curves like that, the trapeziums will actually not give enough area. So sometimes there's questions on whether it's an overestimate or an underestimate, and that's how you can tell. So we have the original y equals fx shown in the graph, and it says it has a minimum at 1 minus 1, so it's this one is the black line here. And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. As always with this type of question, we want to get rid of the fractions or brackets if we have any. Here we've got some fractions, so we're going to start by getting rid of them. I'm going to start by copying down the question, and I'm going to give plenty of space, because these kind of questions do get out of control quite quickly. And so we've got 2 over x plus 10 over x plus 10, and then we've got equals 7. So I'm just going to scroll down and just give us lots and lots of space. Put my tram lines in for the equals. Okay, first thing I'm going to do is I'm going to get rid of the fraction on the left hand side. I'm going to do that by timesing everything by x. And don't forget, it's not just both sides, you've got to times all the terms. So we're going to times the first fraction by x, which will just give us 2. Times the second fraction by x. Well, when you times a fraction by something, you times the numerator. So it would be 10x over, and it would be x plus 10. Denominator stays the same. And here it just becomes 7x. Next, we're going to get rid of the second fraction's denominator. So we're going to times by brackets x plus 10, both sides. Okay, so 2 times x plus 10 is just going to be 2 brackets x plus 10, but I can actually just expand it now. 2x plus 20. Then it's going to be 10x, because the times x plus 10 just gets rid of the denominator. And then here, let's try and expand this as we go. And so we do 7x times x, which is 7x squared, and 7x times 10, which is just 70x. Next step we're going to do is just move everything on the same side. Now I normally keep the x squareds positive if I can, so wherever the x squared is, I move everything else to that side. So we're going to collect the 2x and the 10x, and we're going to take away 12x from both sides. So we've still got that 20 on the left hand side, and here we have 7x squared, where is it going to be, plus 58x. I'm going to take away that 20 from both sides, because with quadratics, to solve them, we always need it to equal 0. Right, now, little hint in the question, it says, write your answer to 2 decimal places. That normally means we're going to be using the quadratic formula, and looking at this question, it doesn't look like we can factorise it. So, quadratic formula, we need to know what a, b and c is, or are. A is the coefficient of the x squared, which is 7. B is the coefficient of the x, which is 58. And c is the number on its own, which is minus 20. The quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac, and all of that over 2a. So, putting in the numbers, it would be minus brackets 58, and I always put brackets around these, because if they are negative, it makes it a lot easier and a lot more reliable. Minus 4 times the 7 times the minus 20, and all of that is going to be above 2 times the 7. Okay, so we type that into our calculator with a plus first of all. So you get your calculator out, type all that out, and you should get 0.331, etc. And then on your calculator you go back to that plus and change it to a minus, and you should get minus 8.62. Oh, hang on, that's not quite right. 8.617, blah blah blah. Rounded too early there. And then when you round those, you should get 0.33 to 2 decimal places, and the other one will be minus 8.62 to 2 decimal places. And looking at that, we're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2, and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3. And it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187, and let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. You can complete a unique version of this paper by going to our OnMath site,
On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.